Welcome back, guys. I'm going to discuss today method of joints. This is a continuation of the earlier video which I have uploaded. We have seen that in that method of joints consists of analyzing trusses by applying the principles of equilibrium to the concurrent force systems acting at each joint. The principles of non-concurrent force systems may be applied to truss analysis. The procedure is known as the method of sections. So, for example, we have here the force problem where we are asked to find the force acting in members BD. You have here this BD, and then you have here BE, and then CE. Using the method of sections, we can calculate these forces. So in each case, determine the force by means of an equation which does not involve the other unknown forces. In other words, we just have to determine the force which we are interested to, to calculate, just like for BD, BE, and then CE. So the required forces for BD, BE, and CE can be found by passing the section AA, this one, through these members. Since the original truss is in equilibrium, the two segments into which it is divided by cutting plane will also in equilibrium if the loads carried by the cut members are replaced by external forces. So meaning if we are going to cut here, there will be an external forces acting here. Could be like this one. Now these external forces, which I'm going to show in the next slide, acting on the FBD of the left segment of the truss. We're going to select that left segment. As you can see here, as there are in this left segment smaller forces compared to the right one, that it will be practical and easy to analyze if you're going to consider this left side. Now to determine the value of CE, where's that CE? This one. We use an equation of equilibrium which eliminates this BD and then BE. Since BD and BE intersects at B here, these forces have no moment about B. Hence, we can apply the equation by taking moment here at B. In other words, this BD and BE is already zero. Thus, we only have CE, this tension for CE at this direction with a distance 8. And then you also have here, this one is also not included. We also have here 1800 at a distance 12. Now this one's negative since it's in opposite direction. Okay. So you can also have all clockwise is equal to counterclockwise forces or moment. So we can compute C is equal to 2,700 pounds, which is tension. Obviously, bottom chords are expected to possess tension forces. Now, it is convenient to replace force BD at joint D with these components, meaning we resolve these components and take moment at joint E to eliminate CE and BE. Thus, if we take moment here at E, first we have this BDH with this distance. If we are going to take this one as positive, then you have this also 1,200 pounds going in this direction also, and it's also positive counterclockwise direction. And then you have here 1,800 in this direction, which is clockwise, and that becomes negative. Thus, we can have BDH or the horizontal component of your BD, which is a total, which is equal to 2,400 pounds. Now, using ratio and proportion between the force and then the slope triangle that we have, this one, obviously this is uh, 3, and then for BD, I should say this is 3 and 1. So this is 3 squared plus 1 squared, or 9 plus 1. This becomes 10. So by having ratio and proportion, BD, this part, okay, so we have this one, BD is to square root of 10, this one is square root of 10, and then you have BD vertical, which is to 1, and then BD horizontal is to 3. And thus we can compute BD, since we already have the horizontal component of BD equals to 2,400, Thus, BD force is equal to 2,530 pounds. Now, if it is also convenient to replace BE with these components, and then we are going to take moment at joint O, by which here we can eliminate BD and then CE. In other words, we can have here BE vertical, this BE vertical, we take moment at joint O, in this direction, let's say this is positive, this is 12, 12, another 12, this becomes 36. And then you have minus 24 since this is in opposite direction, 12 and 12 is 24. And then in a counterclockwise direction again, 1800 times 12, okay, will give us BE vertical, which is equal to 200 pounds. Now, by using proportion between the force and the slope triangle for BE, you have here this one, of course, this is 3, 9, and 4, this is 13. If this is 3, this is 2. In other words, this one is square root of 13. BE to square root of 13, horizontal of the BE, horizontal component of BE to 3. This is 3 here. And then 2 for the vertical. And that's why, since we have already BEV is equal to 200 pounds, we can compute the BE force. Now we can check if our calculations are correct. All the horizontal component, you have here CE minus BEH minus BDH with the relationship of the ratio proportion that we had in the earlier slide, meaning this is equal to 0, though it's in equilibrium, that's one. And our calculation is correct. Similarly, we also have for the vertical component, you have BEV here, and then BDV minus because it's here, and then 1,800 going up, 1,200 up as well. Then we can have equals to 0, meaning our calculation is correct. Thank you guys. Don't forget to hit the subscribe and uh, hit also the notification bell for more videos.